Okay, let's start recording on this. So we're gonna do a revision for more calculations, okay, for this revision video. So we're gonna be completing this particular page over here. This will give a very good summary on how to go about doing chemical calculations. Okay, so let's start with something a little bit more basic first. So let's start with the MR of substances. So how exactly do you calculate MR? MR stands for relative molecular mass or relative formula mass, or it can be relative or molar mass as well. So MR, okay, sorry, let me get to my pen. So first thing really is to look at MR. Is something that you see very common. So what could it stand for? It could stand for molar mass. It could stand for relative molecular mass, or it could stand for relative formula, okay, mass, either one. Now, I won't be looking at the definition of itself, but really more of like how to obtain MR for calculations. Okay, so to find the MR of a substance is really the sum of the relative atomic mass in the substance. Now, this may sound a bit weird, like how do I exactly do this? So let's look at it. So example, if I want to find the MR of H2SO4. H2SO4, what are the elements present? I got hydrogen, I got sulfur, and I got oxygen. Now, how many of each element do I have inside here? So I realize in this H2SO4, I got 2 hydrogen, 1 sulfur, and 4 oxygen. So what I'm going to do here now is to find their atomic mass next, relative atomic based on the periodic table. So if I were to look at the periodic table, hydrogen, the relative atomic mass will be 1. For sulfur, relative atomic mass will be 32. For oxygen, the relative atomic mass will be 16. So in this case, it will be 2 times 1 plus 1 times 32 plus 4 times 16. So if you were to press your calculator, okay, going in, press your calculator, this will actually get you 98. So learning how to calculate MR, that will be important because subsequently we'll be using that for a while. Okay. Now, so once you know how to calculate MR, we can actually do one of the interconversions here. Okay, so we're gonna look at how to interconvert between all of these various quantities. So let's start. First thing, mole of a substance, how to convert to a mass of a substance. Now, because molar mass is actually the mass, think of it as molar mass is like the mass of 1 mole of substance. In this case here, if I got a mole, I got the MR, I can find the mass, because if I take the mole, multiply by the MR, I'll get the mass of a substance. Okay? Because the molar mass is the mass of 1 mole of the substance. And hence, if I got 2 mole, I just take 2 times the molar mass, I'll get the mass of the substance. Now, the reverse is also true. If I want to find the mass of a substance to the mole of a substance, I'll just divide it by the MR. Okay? So this is the first interconversion that we have done. Next one, okay, mass of substance to mole of substance. We have done this part here. Next, let's go into what exactly mole stands for. So think of mole as like a quantity. What is an example? For example, right? When we look at the number, when we say a dozen, okay, let's say when we say dozen, we know represents 12. So if we know I say 1 dozen, it means 12, 12, right? If I say 2 dozen, I know it's 24. In this case here, when I say mole, mole doesn't represent 12. Mole actually represents 6 times 10 to the power 23. Is this big number over here. So if I want to convert mole into number of particles, actually I'll need to multiply by 6 times 10 to the power 23. Let's put a bracket here, because 6 times 10 to the power 23 is like the quantity. Now, so if I got 2 moles, it'll be 6 times 10 to the power 23 times 2, right? So it'll be 12 times 10 to the power 23. Okay? Now, the reverse is also true. If I know the number of particles, can be number of molecules, atoms, or ions, if I want to convert to mole, this will be divide by 6 times 10 to the power 23. Okay? So knowing how to interconvert between this will be important as well. Okay. So we are done with molar mass. We are done with the mole of a substance to number of particles. Next, we're going to look at this concept called the molar volume. molar volume. What exactly is the molar volume? It is the volume of 1 mole of substance. Okay, so the question is, sure, how do I know what's the molar volume? Okay, if you remember, we always go to this idea of 24 decimeter cube or cubic decimeter. So we say that 1 mole, okay, let me erase this instead of saying like that. Okay, at room temperature and pressure, RTP stands for room temperature and pressure. Okay, 1 mole of gas, okay, occupies 24 dm cube of space. Okay, so this is the molar volume of the substance. In this case, when I say if it contains 2 mole, or if there's 2 mole of gas, how much space does it occupy? With 2 times 24. So in actual fact, to convert mole to volume of a substance, I'll actually multiply by 24 dm cube. Now the reverse also holds true. Now if I want to convert volume to mole, this will be divide by 24 dm cube. Okay, so knowing the interconversions between them, that's important. Now sometimes questions can give it in cm cube. So what if it's in cm cube now? So just take note, 1 dm cube is actually equals to 1000 cm cube. Hence, if I don't want to use dm cube, okay, let's say I don't use dm cube, I want to use cm cube. So to convert mole to volume of gas, actually you must multiply by 24,000 cm cube. Then your volume of gas will be in cm cube. And then if my volume of gas is in cm cube, I'll need to divide by 24,000 cm cube. Okay, so take note of the units here between dm and cm cube. Very common. Lee will be used to test you. Okay, so they may not give you dm cube, they may give you cm cube. You will need to convert between them. Okay, next one. Okay, so we are done with the mass of a substance. We're done looking at the mole of a substance, the volume of the gas of a substance, and the number of particles. These are the 4 main quantities you can look at. Now I'm going to add in another 2 more. Okay, next one is concentration. Now concentration, if you look at the units, is mole per dm cube. Now from the units you can see here that if dm cube is a volume, mole obviously is mole. So this will, to find concentration, realize is mole divided by volume. And hence, if I got a mole of a substance, if I want to convert to the concentration in mole per dm cube, I'll need to divide it by the volume. And this volume needs to be in dm cube. Okay? So to convert mole to concentration, okay, in this case the concentration is mole per dm cube, I'll need to divide by the volume lah. Okay, and the reverse holds true with a concentration. I want to convert to mole, I'll need to multiply by volume, and this volume I must convert to dm cube. Okay, so this is for this part over here. Let's look at the top. I also got another way to look at concentration, which is gram per dm cube. Gram is actually mass, dm cube is actually volume. So concentration grams per dm cube, actually it means mass divided by volume. And hence, you want to convert mass to concentration in grams per dm cube, I'll need to divide it by the volume in dm cube, okay, in order to get the concentration. But if I got the concentration, how to get the mass? I'll need to reverse it to multiply by the volume, and this volume, remember, must be in dm cube. Okay, so you can see we have done most of the interconversion rate. There's actually one last one for you to just take note of, which is how can I get from concentration of substance A in grams per dm cube to moles per dm cube. How to get from here down to here. Now, you realize both of them is per dm cube. So actually I can ignore the per volume and just focus on how to get from mass to mole, which is very similar to what we have on the right hand side over here. Okay, to get from grams to mole, okay, or mass to mole, actually what you need to do is divide by the mR. So if I can divide by the mR, I can convert my grams per dm cube to moles per dm cube. And obviously the reverse holds true. If I want to convert mole per dm cube to gram per dm cube, it's like similarly converting moles to grams. This will be multiplying by the mR. Okay? So this is actually all the conversions between the various quantities of a particular substance. Okay, so I'm going to convert mole to mass, mole to volume, mole to number of particles, or mole to concentration. All of the interconversions is here. So get familiar with them. Actually, by looking at the units, you can roughly know what to take note of. Okay, how to do the conversions between them. Now, what other formulas do you need to know? Okay, you realize, how come this one substance A, right hand side substance B? Because in chemical calculations, if they talk about a particular substance, okay, at the start, they may actually ask you find substance A going to substance B. For example, later on you'll see some questions. But let's say I want to find maybe mass of A. I want to now find the mass of B. You cannot just jump directly from here to here. You can't. Okay, in order for you to go from one substance to another substance, you will always need to use what we call the mole ratio. Okay, mole ratio. Now, and to get from mole of substance A to mole of substance B, you always need to multiply by the mole ratio of B over A. Now, question, where does this B and A comes from? Let's say, for example, I got N2 plus H2 gives me NH3. Okay, N2 plus H2 give me NH3. If I balance it, it will be 3 over here and 2 over here, right? Let's say substance A. I say A is nitrogen. I say B is ammonia. So for example, I want to find from the mass of N2, I want to use chemical calculations to find the volume of NH3. Okay, so from the mass of A, which is N2, I need to go to the volume of B, which is NH3, right? So because it's going from one substance to another, from A to B, I must multiply by their mole ratio. So what is the mole ratio for this particular conversion here? So take note, it will always be the number just in front of a particular substance here. So in this case, the mole ratio will be, so the mole ratio will actually be equivalent to 2 over 1. The 1 is over here. Okay, so to be able to determine the mole ratio, you need to look at the equation, and then you need to look at the big number, the reacting ratio, okay, between the two substances that you are comparing. The one that you are trying to find would always be B. The one that is given to you in the question, or I should say the one that give you the starting quantity, that will always be considered A. Okay, now, so we are done with this part here. The rest of all these conversions over here is actually exactly the same as what you have seen on the right hand side. So we will go back, we won't go into details for this part here, right, because you can fill it up on your own. Okay, so that's the formulas that's relating most of the formulas there. Now there's two more additional formulas that I just need you to remember as well. Questions can sometimes ask you to calculate percentage yield or percentage purity. Percentage yield is like what's the percentage of product formed. Okay, percentage purity is how pure the particular substance is. So how to exactly find them? So take note, percentage yield, the formula actually is actual yield. Okay, what's the amount of product formed divided by the, okay, sorry, oh no, I realized all gone. Never mind. Okay, so since we are here already, let's just continue with this. So this will be actual yield, okay, divided by the theoretical maximum yield. So theoretical maximum yield, multiply by 100 because it's percentage. Okay, so to find percentage yield is actually trying to find out what's the amount of products formed, actual, divided by, if I calculate what's the maximum that I can get, so I do a percentage over them. Now, take note, the percentage yield will always be less than 100%, okay, or equal to. It will never go beyond 100%. Okay, now, how about percentage purity? Percentage purity, how to go about finding it? Okay, it's always taking the mass of pure substance in sample divided by the total mass of impure sample. So it's always the amount of pure substance divided by the mass of the impure substance times 100%. So same thing, because it's a percentage, this will always be less than or equals to 100%. Okay? So for example, I want to find the amount of magnesium inside an impure sample. So let's say my impure sample I know is 1.2 grams. My magnesium that I find based on my calculation is 1 gram. So this will actually be 1 over 1.2 times 100. Okay, so that's generally how you do about doing your calculation for this lah. Okay, so that will for this part here to use the flow diagram. Okay, the next part, which I will record again in the next video, will be actually to use this and to go through some questions with it. Okay, so that's all.